Good afternoon, everyone, and welcome by this next press conference. I worked on this press conference together with Tricia Holly-Davis from the Willis Network, and we've got a slightly different format than usual. So Tricia here will introduce the topic and the speakers, and will also moderate the session. Please go ahead.
Thanks, Armand. Can everyone hear me? Yeah. It's better? No, much better. As we're a very small group, can I get an idea of who all of you are and what publications you represent before we begin? Starting with the lady there.
I'm Ann Cairns from the American Geophysical Union. I'm not a writer. I'm the Director of Communications and Outreach.
Okay, welcome. Gentleman in the back, please.
I'm from the German News Magazine.
We need a microphone, I think. Yeah.
My name is Axel Bojanowski. I'm from the German News Magazine, Der Spiegel.
Welcome.
Hi, I'm Soko Song from ETH3. I'm a seismologist and I'm not a reporter here, but I'm just observing what's happening here. Just interesting.
Thank you.
Welcome.
I know who Dr. Gunasekara is, so move on.
Randy Shostak, reporter with EOS, a newspaper of the American Geophysical Union.
Okay, welcome. Thank you all for coming. This press briefing is really, will have a focus, first of all, to understand the importance of bringing together various groups that are represented on this panel, which are from industry, public policy or work with and in public policy, as well as academia, and really the role that each plays in understanding emerging risks. And how we define emerging risk really is whether you have multiple single hazards that come together to create new risks that we previously perhaps haven't thought of as emerging. I think Japan would be a good example, as we saw from the earthquake, which triggered tsunami, which then really ultimately caused a severe nuclear threat. It could be a single risk that we're familiar with, but set against a new backdrop, such as changing demographic, presents a new risk. Or it just could be something that's not on our radar at all. So with that, I'm going to hand over to each of our panelists, beginning with Bruce Mahmoud, who will give you his perspective and expertise, and each of our panelists will take a few minutes to tell you about their own areas of expertise.
Okay, so my name is Bruce Malamud, and I have two hats here. First of all, I'm representing the European Geosciences Union. I'm on the council, and I'm chair of the General Assembly here. So the other hat I play is I am outgoing president of the Natural Hazard Division, which is a very large division here with over 1,750 abstracts across many of the different hazards: wildfire, earthquakes, landslides, technological hazards, etc. And my interest, I actually very much encouraged this particular group of people to come here to the EGU because we are trying very strongly to get academics, academic scientists working with industry, and also ultimately working with policymakers and the public. And so this represents part of that effort to do this. Just one other comment before I hand over to other people. My own research ranges from looking at the statistics of wildfires to landslides, earthquakes, floods. And I'm particularly interested in how these single hazards might group together to form something that is larger than the whole, so that you might have wildfires, for instance, in an area which would later then result in more flooding or more landsliding. And this is something that's only recently really being taken by the natural hazards community to think about. So that's one sense of the emerging risks. The second sense is that you might have a single hazard that intersects a particularly vulnerable area, as we saw in Japan, and that we see something occur that we really had not thought about before in terms of the vulnerability of the situation. So with that, I'll hand back to our chair.
Great. Thank you very much, Bruce. Gordon Wu is a catastrophist who works with risk management solutions. If you're not familiar with risk management solutions, they're a modeling company, the catastrophe risk modeling. Gordon.
Okay, thanks very much. Yes, I'm in the emerging risks section of RMS, specializing in analyzing risks which are not really on the radar screen of our clients in the insurance industry. Now, here we are sitting in this building in Vienna, and literally only a couple hundred meters away from here is the headquarters of the International Atomic Energy Agency. And in fact, I was there 3 years ago drafting the new guidelines for the seismic safety of nuclear power plants. And this is a classic example of what I would describe as a risk which is not on that many people's radar screen. So for those who are not actually in the industry of advising nuclear operators on the safety of nuclear plants, is something they hadn't really figured was a real risk until obviously what happened just a few weeks ago. So this is a classic example of how a geological hazard like an earthquake can cause a tsunami, can cause a major nuclear disaster, the repercussions of which are still to be realized in terms of its impact, not just in Japan, but in neighboring countries as well. Thank you.
Thank you, Gordon. To my left is Pierluigi Vidal, who's the Willis Professor of Climate System Science and Climate Hazards at the University of Reading. Pierluigi?
Morning. I am in nature a global climate modeler. So in this I stand at the origination point where we try to understand the nature of the hazards, and actually we synthetically produce hazards like storms. Our interest is in the natural variability of weather and climate and on how these may change, for instance with climate change. Examples of our interests, hurricane, typhoons, and how they are connected globally with other phenomena like El Niño, for instance, and how this may create teleconnections that would cause in a particular year 2 different regions of the planet to be hit in a very particular way by these types of hazards. And our other interest is in understanding how these teleconnections may change. The nature of what we do is meant to help us complement the observational evidence, which is very short. And the idea is to understand what things may already have happened on this planet, but we've never observed. We have no idea that have occurred. An example is the hurricane that hit the coast of Brazil a few years ago, which was completely unexpected. Probably had occurred before, but had not been observed. The idea of using models and synthesizing this information is to try to see things that we would not know otherwise. I'll stop there.
Thank you. And finally, we have Gero Michel, who's the Managing Director of the Willis Research Network. Dr. Michel?
Good morning. Pleasure to be here. I represent here the angle of more using or understanding or what we learn here in science and use that further in the industry, which is related to the insurance and reinsurance industry. So with that, we have created some time ago and started in 2006 a network which comprises now in the order of 45 institutions around the world, scientific institutions, whether it's Princeton, Wharton School of Economics, it's Oxford, Cambridge, Kyoto. So it's all around the world. All those that we understand are the leaders in their own field in hazard and risk. A large part of that is surely emerging risks and looking into the unknowns, looking also in systemic risk and things like that.
Great. Thank you very much. I see some more. I think we timed that perfectly. Excuse me. Hi. Please, yeah. Not at all.
Previous session, everyone.
No, please. Yeah. And on cue, we have Stuart Lane, from Professor of Geomorphology at the University of Lausanne. So the idea is to tell everyone why you're here, what you do, your specialty. So maybe we'll speak into the microphone.
Okay, I'm been a member of the Willis Research Network since 2006, and I was formerly in Durham University, where I directed an Institute of Hazard Risk and Resilience. I'm a natural scientist. I do mathematical modelling in both hydrology and geomorphology, but I have a particular interest in risk and risk management in terms of how that can be better informed by science.
Thank you very much. I'm going to here so we can share the microphone. Yeah. Okay, so you have hopefully a very good sense of this very distinguished panel. And again, the subject that we're all here to talk about is emerging risks, as Bruce very eloquently defined earlier. So do we have any questions from the floor? Yes, please. Yes. Amand in the front, yeah. Sorry. Would you mind, just restating your name and your affiliation? Thank you.
Sure. Randy Shostak, reporter with EOS, newspaper of the American Geophysical Union. I guess perhaps for Dr. Malamud and some others, you'd mentioned that the multiple hazard risks is something only recently taken up by the natural hazards community. So I wonder if you can give me a little bit of a history of that, why it's taken until now for the hazards community to look at this.
Yeah, thanks, Randy. I mean, basically, when I say it's only being recently taken up, I'd say really recently being taken up quite seriously. We've always been aware, of course, that certain hazards will trigger other hazards, that certain hazards will interact together with them. I think from my own perspective, and there are many others here to correct me on this, many in the natural hazards community tend to be very narrowly focused within their own themes. And that's something I encountered when I first came here to the EGU, was people were wildfire experts, they were landslide experts, they were earthquake experts, they were tsunami experts. Often the earthquake tsunami experts did work together, obviously, but you did not often get wildfire and landslide experts working together. And over the last decade, there's been an increasing call for multidisciplinary research. Now, many people think of that as physical social sciences together, but it's also trying to take people from cognate disciplines that are very close to each other and have them work together. So what I'm seeing is that there is increasing interest in looking at single hazards together, you know, wildfires, earthquakes, floods, and pulling them together and saying what would be the resulting emergent risk from these. All right. Does that answer your question? Okay. And I don't know if anyone else wants to apply.
Just follow up. The European Union centrally funds a lot of the scientific research within the countries forming the Union. And as of just last October, the European Union has funded a really major project on multi-hazards. In fact, I have a sort of small part in this project, and this covers all the natural hazards. And one of the prime aims of the project is to help the key government decision makers to figure out what are the best ways of dealing with this whole range of natural hazards in Europe, which up till now have been sort of put in silos and just looked at separately. So I think this is just so Europe catching up perhaps with other parts of the world, but certainly there is this major project just starting. Now, if you want the name of it, it's actually called Matrix, M-A-T-R-I-X, and it's just been funded as of last October. It's rather contorted acronym, which is rather embarrassing. So I think one of the keys to getting any European project funded is to come up with some sort of cool acronym, and usually the English language comes off worse with the choice of these acronyms. So I won't even bother to try to explain what the matrix stands for. Thank you.
That's typical for scientists, isn't it? They just care about what makes sense. I think there's another angle on that, and that angle comes from the industry itself, and that's the idea of diversification. And in many ways, we have believed in diversification and looking into perils individually, what we call perils or hazards, individually, and in some ways, especially if you go into the financial market, even think there's negative correlation, you can essentially diversify it away. I think it's more recently, and that's surely also in the financial market, that we agree more and more that, especially in the tail ends and the very high severity, things might correlate much more than we think or thought before. And I think that's surely another angle which is becoming more and more important now.
The phrase I use is a conspiracy of events, in effect, which is where you actually have, as Gero has just explained, the interaction between two events. And I think there are or events that are implicitly correlated. Now, I think there are two real difficulties for that. The first is, if you think about it mathematically, when you take two signals, both with uncertainty, those uncertainties don't add linearly, they multiply. In other words, events that have conspiracy are much more uncertain, but they tend to have a much bigger signal. And that means that they are very, very difficult to actually think about mathematically. But the second problem that I think is also very, very serious, and it relates to something that Bruce said, which is a lot of the risk management tools that we've developed have effectively been based for single perils. And then what you end up with is the maps, if you like, if it's some kind of zoning type management, get laid on top of one another. Whereas unfortunately, because there's interactions between the maps, the actual events tend to be much more serious. And I mean, the classic example of that has been in attempts to model flood risk, which have often assumed that all of the flooding comes from the river, whereas many properties actually get flooded by direct runoff from the hill slope, and the flooding is then much more serious because you get the interaction between the river flooding and the hill slope flooding. And it's in those kinds of situations where you end up with a policy that is based upon a simple superposition of supposedly independent risk maps when actually they're interacting together. And that's very serious, I think, and one of the big areas for risk management to try and address.
Right.
If I may add something from the point of view of the study, understanding of the hazards, there are also technological limitations. The type of atmospheric and oceanic models that we use for these problems are computationally very expensive. And in the last maybe 10 years, we've seen quite an increase in computational resources, but nowhere near what we need yet. We're all asking for something very substantial. But just to give you an example, last year we had a really interesting case of two types of atmospheric caused events, the heat wave in Russia and all the fires, and the flooding in Pakistan. These are very well connected in the atmosphere. The phenomenon responsible for that is called blocking and requires very high resolution. The types of models that we could afford to run for these problems were the typical weather models that we can run for a few weeks at a time. What we need, in fact, are simulations that we can carry out for many months, possibly seasons, in massive ensemble mode, but at such high resolution that this would require really substantial computational resources. The other example is hurricanes and El Niño. For El Niño, we need hundreds of years of simulation to see a significant sample. But for hurricanes, we need extremely high resolutions, so we can usually only afford to run these models for very few days. These are two ends of a spectrum. We should try and bring those things together, because yes, they are very highly correlated, but the time scales and spatial scales are very different. So technology plays a role too. And I mentioned the issue of observations. Observations are very short and very sparse in space and not very homogeneous. So.
Thank you. Any other questions from the floor? Comments? No? The floor is yours. Yeah.
Well, I wanted to ask, related to the recent tragedy in Japan, and I guess a couple of related questions to that. First of all, how does the multiple risk that happened in Japan with the earthquake, tsunami, and the nuclear tragedy change the way that you think about multiple hazards and about risk? And also, how, given what you just said, Dr. Vidal, about models and the cost of doing models and simulation, how far and how much can you do with modeling and simulation when we're looking at the vast Earth history of so many things that we don't know? What can you focus on? Where do you pick your battles? Most seismologists never expected a 9.0 magnitude on the location where it was. We only have so many years of data.
Yeah. Do you want to begin?
So, in fact, what you just mentioned, discovering things we didn't know that exist and could have hit us, is part of what we do with our. I certainly don't simulate tsunamis with our climate models. It's not part of our current capability. it is a completely different problem from what we normally look at. But certainly discovery of things that could potentially hit us is part of our remit. And what we do with these models is actually many times we develop them based on physics, and we run them long enough to see emerging processes. So we run them under very many different scenarios. We possibly run them for thousands of years, and we start to look at things that are absolutely not in the observational record, and we try to understand whether or not these things are credible from the point of view of the chain of mechanisms that originates them, and how these things are interconnected. And we try to learn from that. Similar approaches could be taken with other disciplines. But if you look at the history of the development of Earth system models, they started off as very simple weather models, and later they were coupled to an ocean, and later were coupled with a land surface. And as you move in history, more and more physics, more and more biology, more and more chemistry are added on, and the complexity of these systems is ever increasing. So certainly there is a direction that has been followed in trying to bring it all together, but it's a huge problem. It's really a grand challenge.
Please, Bruce.
Just want to respond to two items there. The first is that most seismologists didn't expect an earthquake of that size. I'm not sure that's quite true. I mean, there certainly was an expectation that there was a very low probability of an earthquake of that size occurring. And there is literature out there in the seismic community looking at the relative stresses in that particular area of the subduction zone. So, you know, I don't think it's that they didn't expect it, it's just that there was a very low probability of something occurring. And the question then is, to what kind of return period or expectation are we as politicians and the public trying to guard against? So there is that issue. The second one is, you asked whether the combination of the earthquake, the tsunami, the nuclear hazard is going to be changing how we think about things. Certainly the earthquake and tsunami, no, we have better awareness. Of course, we know that when there's a big earthquake that there is a possibility of a tsunami resulting. I don't think that awareness will be changing a huge amount. What will be changing quite a bit, and we've already seen this happen, is a questioning everywhere whether nuclear plants are appropriately placed. That is one question that's being asked in quite a few places, sometimes scientifically and sometimes very emotionally. So that is happening. The second thing that is changing, I think, is that there's a better awareness of the potential of tsunami. So people, each time a large tsunami occurs, people in countries that are normally not at threat, i.e. have very low probabilities of threat, ask themselves, are we at threat? So I was with some Viennese journalists a few days ago, and they said, are we at risk of a tsunami here? Well, probably not, no. But is the UK at risk? Well, yes, you know, there have been tsunamis in the 800s, you know, from very large landslides. Earthquakes are not the only trigger mechanism. And so it's that awareness, and that is being brought a bit more, I think, to the front, that there is the possibility of tsunamis that are not earthquake triggered. There are also landslide ones. There are other mechanisms for tsunamis, and that awareness is being risen again. Okay.
Yes, please, Gordon.
If I can just pick up on comments Bruce made about the small probability considered for an earthquake of magnitude 9 to occur, where it did. A point which needs to be understood about the whole industry of the seismic design of nuclear power plants is that traditionally in many countries there was a deterministic approach to seismic design. So they weren't designing for an event which might have a very small chance of occurring. They designed for what people thought was a pretty reasonable estimate of what the worst case was. And Japan was one of those countries. And I think it's well known throughout industry, okay, that the Japanese have always been excellent at commercializing inventions made in the West, whether it's electronics or automobiles or whatever. But they've often been criticized for not really being very innovative in terms of fundamental science. I think that's well known. And this is really exemplified in the whole domain of probabilistic seismic hazard assessment, to which the Japanese have contributed remarkably little. Remarkably little for a country as seismically active as Japan to have contributed really very little to the science of doing seismic hazard probabilistically. I mean, just the way things have been. I mean, the biggest contributors have been in America, and even so people like myself working in Europe have made contributions in this area. But in Japan, they've never really had their heart in tackling this problem in a probabilistic way. So when it came, for example, to designing the tsunami sea defences around the nuclear power plants, is a case of saying, well, what do you think the worst case event would be? Okay, and if that happened, what would the maximum tsunami height would be? Okay, let's call it 5-6 meters. Okay, and clearly that's inadequate, and obviously there's going to be a rethink. But I think it's important to get behind the decision making to understand the culture. Each country has its own culture for looking at hazards, and there's some things about Japanese culture one really admires. In particular, the Fukushima 50, who have put their lives at risk to help save their country from a worse disaster than it already is in going into the nuclear power plants and so on. But certainly when it comes to, say, a young graduate student coming up with a new approach to seismic hazard assessment, which were knocked down by his professor and so on, that Japan is not really a great country for encouraging that kind of innovation. And in fact, just a few years ago, there was an earthquake which occurred near Niigata on the other side of Japan, which did cause some damage at a nuclear power plant in Japan, but fortunately it shut down safely. Okay, but I think it is important to understand the root causes of problems, and I'm a great believer in the fact that there are no such things as purely natural disasters. There's always some man-made element in there somewhere, and this is a classic case that there is a very strong man-made root to this particular disaster, and you can call it sort of culture or whatever you like, but there is a strong element of that in this disaster.
But very quickly, what have we learned in the industry? And I think we are learning, because if you look around, it's the much smaller earthquake in New Zealand, which has finally, hit design codes very unexpected, within the order up to 2G, and which was really not in the models. I think one of the big challenges we all have is that we go for a consensus approach. We use, like for Japan, we all finally come back to the same understanding of hazard. And this consensus approach is coming back to essentially one model in many ways, although there might be a few, a few different varieties on it, or it's probably not the right thing to do. And I think that's what we more and more learn now in the industry, is allow a larger variability, allow a larger range of possible outcomes, scientific outcome, to help us making decisions. So this decision-making under uncertainty is changing with that, and it's not only the New Zealand, it's Japan, but look into many others. What we call black swans, which essentially events which were unknown before, uncertain, and then suddenly they happen, and afterwards we all say, oh yeah, we know what that is. It's very normal. I mean, we've seen it, whether it's September 11, whether it's the Kobe earthquake, the Northridge earthquake, it's all over the place. Katrina is in many ways the same thing. So it's all related to the fact that we just look too narrow into risk ourselves. I think one angle, just to mention in as well, we should be a bit careful about perception and how we see tail. We all tend after an event to over-exaggregate tails, and now everything is much worse. But that much worse is a huge cost. And I think, at a certain point, we will not be able to pay for it. So we have to be very rational in our thinking, and have to think, if we see larger risk in some areas, we probably see lesser risk in other areas, and really work that way. So there's more to do.
Let's do it. Yeah.
I'll take a slightly different tack to what we've been talking about, but it chimes, I think, with some of the responses, particularly Gordon's response, which is that one of the difficulties that we have in risk management is we've built up, by necessity, we have to do this, a series of risk management tools. And those risk management tools have to make assumptions. They have to make assumptions not just about the natural environment, but they have to make assumptions about the social environment at a range of scales, whether it's the scale of the individual decision maker in a nuclear power station, right the way through to the scale of a government. Now, what that means is that our whole risk management procedure, which is founded on this, will only be sustainable if we can make the world look like our models. Okay? Now, that's a bit odd because we would normally expect our models to look like the world, and we hope that they do. But when we have an event, all of those assumptions get uncovered, and we start to see where we've gone wrong. Now, that's where the role of science is very important, because I think that what science can do is it can actually look at the extent to which our models genuinely do look like the world, and avoid us getting into the situation, which is an impossible situation, that we have to make the world look like our models, because we can't do that. Now, where science is then important is being able to do that not simply, as Jerry's just pointed out, when there are the tails happen, but it's throughout the process of the ongoing rolling on of science, of society. And that's where I think the critical thing is to make sure that the doors are open for new scientific thinking to come into the risk management process, so that the risk management process doesn't get locked in and stuck on a particular way of doing things. I think that thinking about that relationship between the world and the model is an interesting way of thinking about it.
Great. Thank you very much, gentlemen. I appreciate your time. Yeah. Any other questions? Oh, you do?
More time?
Yeah, I think we have a few minutes. Yeah, yeah.
Absolutely.
Sure, we have.
Yeah.
I wonder if you could just elaborate a little bit more on where sometimes things have gone wrong in terms of thinking about and limitations.
I mean, yes. Classic assumption, let me give you an example of this, is the assumption of rationality. If only we could educate people as to where risk is in our world with respect to a particular peril, they would behave much more rationally and would avoid taking that risk. Two observations. The first is that a large amount of research done in the social psychology literature has showed us very clearly that people will only respond to warnings if they've recently personally experienced the event themselves. The classic example of this is earthquake. A study in 1969 on earthquake insurance found that after a major earthquake, there was a very big uptake of earthquake insurance by the people who were affected by this event, even though it was at that time that the probability of them experiencing another earthquake had fallen dramatically. It's often called the example rule. In other words, what we do in risk, in terms of our risk management, is we sanitize our landscapes of risk. Flood risk does this, for example. We remove all the little events, but we still have big events. And in doing that, we change people's experience of risk in ways that, on the one hand, protect them from experiencing that risk, but on the other hand, reduce their ability to experience risk when it does actually happen. And it's actually that's not an irrational behavior, because in our day-to-day lives, we experience a multitude of factors that determine how we live, not just risks, surviving an economic crisis, personal situations, all the things like that, such that we can never assume that all of the possible risks that are out there can be factored into our day-to-day activities all of the time. And that's a classic assumption that we make, that simply more scientific information will lead to better, more rational decision-making by those who are at risk. Those people who have to take their decisions have the problem that what will make them take particular decisions will be experience. We've taken a lot of that experience out of the world, and unfortunately, and quite seriously, it's getting increasingly difficult to persuade them to displace one set of concerns by the particular concern that we want them to raise in their understanding. And that's been well discussed for 20 or 30 years, but it's often forgotten.
Bruce, then Gordon. Yes.
Okay. Yeah, just to add to that, since I come from the probabilistic hazard forecasting point of view, I think one of the issues that for people that deal with extreme events that we're constantly dealing with is we have very, very few values that big to deal with. And so when we start trying to extrapolate these probability models, we can often make very, very large errors because the variabilities are so large. And this is what was being discussed by Stewart and Garrow in terms of the tails of the events. Basically, that if the very large events, the number of events of a given size falls off as a normal distribution, it's going to be very different than if it's something that is much more conservative, such as a heavy tail distribution or a power law. And what there has been a move towards in the last probably decade is the understanding that many natural hazards actually fall off in terms of a statistical distribution that is very non-normal. It's much more of a heavy tail. And this difference can make a very, very large difference in how we perceive the actual probability of something occurring. So how often something might occur. That was one issue. The other issue is what Stewart was also talking about, was the idea that if we protect against a bunch of small events, this can actually have another effect. So if you take a bunch of small wildfires and you keep putting them out, then you're going to have all of that underbrush still there, and the result will be a much larger wildfire. And so these are two classic places where, you know, we believe that we've had some significant errors in the past in the hazards community in how we assess the risk or how we protect ourselves against risk. Okay.
Yes, I'd just like to make a general comment about this particular conference, which is that I think everyone who has some kind of interest in the geosciences needs to be aware of the greater landscape upon which political decisions are made. And I think there's no better example of this than with the soul searching over the future of nuclear power in the world. Now, if you take Britain as a country, the Labour Party was absolutely against any development of nuclear power in Britain. For years, that was the policy, and it changed overnight. What was that night? It wasn't any natural hazard event. It was a political event when President Putin turned the gas off to the Ukraine because they hadn't paid their bills. Because so much as people in Britain don't want to be irradiated and have their health put at jeopardy, no one in Britain wants to freeze to death in the winter because of the Russians. And I think, and that's pretty absolute. So I think one has to. I think this is so important that when it comes to any decision which is made regarding any aspect of the geohazards, that this is put in the context of the overall broader picture of all the issues which governments have to address from day to day. It applies to America as it applies here in Europe. And I think it's so important for everyone who works in the geoscience area to understand the bigger picture. And obviously what we try to do is to make this particular part of the picture clearer for the decision makers, but ultimately it's the bigger picture which really counts.
What does it mean, the bigger picture, and how do you bring it really to the people? I think where it went wrong in the past, in part, is communication. And I have a friend, for instance, who created a company, a friend from Harvard, who created a company which is related to young drivers, and he wants to do serious gaming. Serious gaming is the idea of bringing, you know, disasters or hazard, or even if it's just, you know, wrong driving, to people, to bring it into their everyday life. And I think that's where we in our industry, but probably also in the scientific community, we are not very good at. You know, what are the things we can bring to the people, and how can we bring these things to the people? What about serious gaming? Do we find the right games, the right things which attracts people, and how do they look like? And I think I find it hilarious that this event in Japan now, of course, has changed elections in Germany, and the Green Party is not there. But it's just this event. Then tomorrow is something else, and whatever it might be. And then, you know, people change there. And I think we all have we all have a responsibility to more and more discuss in these rounds what really matters, what we think matters, and how can we bring that in a more efficient way to the people.
Anything else? EOS is getting quite a good scoop here today, I think.
Well, everybody on the webcast will get the same thing. I'm wondering, just sort of a broader question, if you could talk about the relationship between scientists, industry, and the insurance company, how you work together or not.
Do you want to start with that, Gareth?
Well, I start that. Okay. I think, frankly, in the past, and that's what we're trying to change more and more with the Willis Research Network, there were some sporadic hotspots of communication, public, private, and that was along mainly a few very large reinsurers who could afford it and look into it. But for the rest of the market, there was probably much less communication there. Then the world brought, a few of these vendors, companies who created models, and Gordon is part of that. And with that brought more science to the industry, but it was in a very focused way. So it was very much looking into specific areas, into specific perils. And it was bringing a consensus view to a large degree. What people in a way needed in this market is in order to compare your neighbor to yourself. Now it's only recently that we understand more and more that this, comparing to your neighbor is probably not everything. There's much more behind that. And so that's why we started the Willis Research Network, and first of all, teach scientists to talk our language, and then teach our clients to talk more and more the scientific language. I think communication is the first thing. And the second thing then, more and more to create tailor-made products that help, so steer science to create products that help the industry as much as possible directly, which hasn't been the case in the past. So this is coming more and more. We're still far away from an optimal way to do that, but we are on the way.
So if I can just speak on behalf of Risk Management Solutions, which is the leading market vendor for models of catastrophe risk. The work that we do is very client-driven in the sense that we try to respond to the interests of insurers in terms of the kind of risk for which they would like to have models. Over the years, a key driver of the kind of interest that insurers have in models comes from people who've really taken up a particular issue and want it really addressed. And so when I think of people like Gareth, that if he didn't exist, he would have to be invented. I think we need more people like Gareth in the market who actually want to try to raise issues within the insurance industry. I remember the days going back to the late 1980s when I met one Lloyd's insurer, and I said I had some expertise in earthquake risk, and he said, well, that's great. Why don't you set up your own syndicate and write earthquake risk? He wasn't bothered. That was just before the Lehman Prieto earthquake in 1989 when the Lloyd's market went belly up. So it's this one thing which people should understand is just how young this whole industry is. It's 20 years old. That's all. And if you go back one generation, there was none of this kind of analysis. And I think it's wonderful to see how far this industry has progressed in 2 decades, and this is just the start. I mean, if we look to the future with faster and faster computers, more of the kind of analysis for weather that's referred to a moment ago, and so on. I mean, there's a huge range of opportunity for future development in this area. And just to echo what Gareth said, that the more that the kind of issues and research raised at this kind of conference is really well received by modelling vendors like RMS, who just want to try to represent as much as possible of the latest science in their understanding of models. But fundamentally, I come back to this point, which is that modelers like RMS can only ultimately react to what its clients actually would want to see. If I could just raise one particular emerging risk, which is that of solar flares. I mean, 2012 is the year when the next solar maximum is meant to occur. Now, nobody knows exactly how big this maximum will be, just as nobody knew how big the earthquake would be on the 11th of March. Okay, so it could be like the Carrington event in the 19th century. It could be a lot smaller. We don't know. Okay, but right now in the Lloyd's market, there isn't a whole lot of interest in looking at this. So at RMS, we've been sounding out the market as to what their interest is in some kind of modelling of what the implications would be, and it's pretty lukewarm. Okay, so this is just an example of how companies like RMS ultimately react to client interest.
Please, yeah.
Just to give the perspective of a non-industry person and from academia, I've sort of watched over the last 10 years the involvement of reinsurance companies and companies like Willis here at the European Geosciences Union. And the EGU really does represent one of the largest kind of collection of academic scientists in the natural hazard community. And what my observation has been is that we've gone from reinsurance companies and other companies which might employ at most one natural hazard scientist to whole teams of actual scientists that are now studying the problem. And also, they're really driving forward from certainly the perspective I've seen, some of this interaction between scientists and public policy in the sense of helping us communicate our ideas, helping better understand what the needs of these stakeholders are. And this really is something I think the reinsurance companies like Willis are driving forward. Obviously, there are other modes out there, such as funding agencies, European funding agencies, the National Environment Research Council, so national funding agencies, which are putting a lot of premium on knowledge transfer, particularly in these last couple years. But it is always the questions for scientists such as myself, okay, I want to do some blue skies research, I want to explore, I want to better understand the hazard, but I also would like to eventually get this out to someone somewhere that might make a difference. And I think as I've said, is the reinsurance companies are helping this quite a bit along with funding agencies.
I think that one of the things that scientists can do, as I've kind of intimated already, is they can unsettle established practices, technological lock-in into particular kinds of ways of modelling or managing a particular kind of catastrophe risk, and that's very important. But Jero said something very important also, which is that scientists need to do that with an understanding of the premise upon which insurance and reinsurance is based, if we take that as an example. For instance, the essence of insurance and reinsurance is the notion that society as a collective can effectively share the costs that ultimately will be borne by a few. In other words, when we think about the science that's needed, and I come very much from a deterministic, spatially explicit kind of modelling history, I have to be very careful about saying that, well, I think I can now say that there will be that risk in 6 months' time in that place. Because in doing that and providing that kind of scientific steer, I will be undermining the very foundations of the whole industry that allows people to continue to live in risky places. And that's why you have to really think very carefully when you're a scientist working within an industry like this about what it is that the industry is there to deliver as a societal function, regardless of whether it's a privatized government insurance pool or public government insurance pool or completely private insurance system. There are certain principles that you have to be very careful of. For instance, it is not entirely clear to me that producing, certainly for the insurance industry's perspective, producing better, more spatially explicit forecasts of risk is necessarily going to be a good thing, even though, of course, we would like to be able to tell somebody in 6 months' time that their house might be flooded. But we have to think about very carefully how far we go down that line, because if not, we will start to create great spatial inequalities in our world, as we label some people as people who are going to be flooded in 6 months' time, who will have all sorts of problems getting insurance for their house. They will have all sorts of problems in terms of selling their house and so on. So we do have to think very carefully about what the science might actually mean.
Yeah.
But don't we already know some of that? Don't we already know that a lot of people with the increase in population are moving more and more into riskier areas?
And this is the very important distinction between risk and catastrophe. Risk, if you like, is a time-integrated You might think of it as a time-integrated, perhaps geographically explicit idea of where risk actually is. That's being able to provide that risk information then allows you to actually work out what your exposure is, and it allows you to work out, therefore, what levels of reinsurance you might need. What you have to be very careful about is turning that into a time-explicit type analysis, because as soon as you start to do that, you will get the kinds of scenarios that have been talked about. I mean, there was a very famous book written a few decades ago that asked the question, what if we could say that Los Angeles was going to have a high magnitude earthquake in 4 years' time? What would happen to the city? And then in the classic 1970s framework of social modelling, they then ran a model that looked at how the city would evolve. And you would see, as you might expect, the ghettoization of the city. Those who could afford to move would move. Those who could afford to invest in their properties to make them more earthquake-proof would be able to do that. So there are big societal questions there that come from the way in which scientists interact with this industry, that scientists have to understand if they're going to make societally valuable contributions.
Mm.
And you're absolutely right. Of course, the risk is also increasing because people get more and more exposed. I think that what comes in there is a kind of an ambivalence or a challenge in our system. I mean, on the one hand, you want as many as possible people to be insured for that. You want probably some government interaction with that. You want premiums not to be too high. People need to be able to afford it. We don't want to see something like in California where the penetration of earthquake insurance is only 8 or 9% now, simply because it's getting more and more expensive. And the less you have, it's getting more expensive even. On the other hand, you want still the private market in some ways to say when the risk is getting too high and therefore bring up the warning signal. Because what you don't want is that the private industry is essentially finally failing when the big event happens because they don't have enough premium. So there's an ambivalence there. There's a very complex system which is not easy to solve, and we see it especially in the United States, where insurance companies move out of the areas of risk. They move out of Florida. They go away from it, and still it's difficult to increase the premium to the point where those companies may think that it still makes sense again. So it's a very difficult thing in that, and I think there are probably solutions to a certain degree, and one solution is to think in certain areas a bit larger, to think about pools, especially when it comes to more emerging territories and areas. Think about even pools that go, over different countries. What we see in the Caribbean. Can we do the same in Central Asia? Are there possibilities for that? Still probably in the private market. We always see a bit of challenges when we allow governments only to administer that, but I think it's always a joint venture, and it should be.
So I would like to make one final point, which is that insurance is a great contributor to the resilience of a country in the aftermath of a great disaster. You only have to compare Port-au-Prince with Christchurch, New Zealand, where Port-au-Prince was virtually no insurance at all, and they just have to rely on the handouts from the rest of the world to reconstruct, whereas in Christchurch they have an excellent pool system in operation in New Zealand, which gives them a huge start in reconstruction. So I think that whatever faults there may be in the insurance system, it's after a disaster occurs that one really recognises the contribution that insurance has to resilience of especially large cities in the event of a great disaster.
Bruce, Pierluigi, any final thoughts? No? Great. Okay. Yeah. Thank you very much, gentlemen. I appreciate your time. Thank you very much for the questions. Thank you. I just want to flag up that we have two sessions. There's a union session tomorrow on emerging risks, how science can aid society in tackling emerging risks, and that happens from 1:30 to 3 o'clock. And then that's in room D. And we have a session on public policy and commercial applications of natural catastrophe risk assessment, and that discussion starts at 4:30, runs to 5:15, and that is in room 7. Thank you. Okay. Thank you very much.